Hi, I'm Roland Minton. These are some of my favorite math stories. In this episode, Mathematics is MathCounts. We'll look at some of the questions encountered by middle school students in a national competition aired on ESPN. You say you've never seen MathCounts on ESPN? Well, if you've seen the National Spelling Bee aired, you might not be surprised that the math version of this competition was shown in 2004 and 2005. I guess the sight of kids confidently nailing difficult math questions didn't have the appeal of kids agonizing to spell or misspell words you've never heard of. What? I have a bad attitude? MathCounts is a competition for middle schoolers, grades 6 through 8, with plans to expand down to grades 3 through 5. Started in 1983 by the National Society of Professional Engineers, the National Council of Teachers of Mathematics, and CAN Insurance. As I hope to show, the competition encourages the development of a broad range of mathematical skills and not the rote memorization of some obscure facts. The team nature of the competition also encourages group participation and support. Obviously, I'm a fan. I'll start with a question used in the countdown round, where the top individuals in the written competition at the regional, state, or national level go head-to-head on problems, buzzing in like Jeopardy to be the first to answer the question. Here's the question. Take the digits 1 through 9 and arrange them randomly to form a 9-digit number, no digit repeated. What is the probability that the number is divisible by 9? If you're still thinking, you've already been outbuzzed. The answer is 1, and here's the logic. As shown in the mod episode, a number is divisible by 9 if and only if the sum of its digits is divisible by 9. 1 plus 2 plus 3 out to 9 equals 45. There is a shortcut for sums like this, and 45 is divisible by 9. So 100% of the numbers constructed this way are divisible by 9. Another part of the MathCounts competition is written. These questions are often more elaborate, and some are done in teams. Here is one. A spiral staircase rises 3 meters, makes 2 complete turns, and measures 1.5 meters from center to outside rail. How long is the outside rail? Well, I love this one because with some thought you can transform it into a straightforward problem. What's the trick? Think of unrolling the staircase into a 2D wall. The wall is 3 meters high, and its length is the length of 2 laps around the circle of radius 1.5. Since the circumference of a circle is 2 pi r, this equals 2 times 3 pi. You have a right triangle with the handrail as the hypotenuse. So the square of the length of the handrail equals 3 squared plus 6 pi squared. The length of the handrail is the square root of 9 plus 36 pi squared. A difficult answer obtained with some visual thinking. Back to countdown questions. Here's another probability question, one that requires breaking a larger problem down into smaller pieces. There are 2 spinners, one divided into 4 equal sections labeled 2, 3, 5, 7, and the other divided into 3 equal sections labeled 3, 4, 6. Both are randomly spun. What's the probability that the product of the 2 numbers is odd? Well, first you should realize that the product of 2 numbers is only odd if both numbers are odd. The first spinner has 3 of 4 odd numbers. The second spinner has 1 of 3 odd numbers. So the answer is 3/4 times 1/3, which is 1/4. The next problem continues the theme of breaking a larger problem into smaller pieces. To do so requires critical reading and critical thinking. If x squared plus x equals 7, what is x to the 4th plus 2x cubed plus 2x squared plus x? Well, realize that you could solve for x and then compute the desired quantity, but that would take far too long. There must be a shortcut. Since x to the 4th is the square of x squared, try squaring x squared plus x. That would be the same as 7 squared or 49. X squared plus x squared, FOIL it out, x to the 4th plus 2x cubed plus x squared, and what we are asked to compute has all of that plus another x squared plus x. But that equals 7, so the answer is 49 plus 7, which is 56. Are these problems of practical importance? Nah, but I would argue that the problem-solving skills they teach are. Here's another one that I like. First, some terminology. The units digit of a number is the far right digit. The unit digits of 123 is the 3. So what is the units digit of 3 raised to the 2026? I followed the math competition convention of using the current year in the problem. Theoretically, you could compute 3 raised to the 2026 and see what the answer is, but that's too large for even computers or calculators, which aren't allowed anyway. Let's do a couple of quick calculations and see what's possible. 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81, 3 to the 5th is 243, so the units digit repeat 3971, 3971, and so on. Where does 2026 fall? Well, using modular arithmetic, again, see the episode mod, we have 2026 mod 4 equals 2, so the units digit of 3 raised to the 2026 and 3 to the 2 are the same. The answer is 9. One last problem. If TESS plus SEES equals ELLEN and different letters correspond to different single-digit numbers, what is T? Notice that Ellen has an extra digit. So somehow T plus S in the far left forces us to carry a 1, and that makes E equals 1. So now T1SS plus S11S equals 1LL1N. In the second slot from the right, S plus 1 equals 1. You would think that S has to be 0, but if S is 0, then the units digit reads S plus S equals N, so N equals 0. But N and S are supposed to represent different numbers, so that can't be. Now, we can get S plus S equals 1 in the 10 slot if we carried 1 from the unit slot. So S could equal 9. So now T199 plus 9119 equals 1LL1N. In the unit slot, 9 plus 9 equals N, making N equals 8. We carry 1 to make 10 plus 1 equals 1 in the tens place. Carry 1 again to make 2 plus 1 equals L in the hundreds slot. With L equals 3, the last requirement is that T plus 9 equals 3, actually 13, so T equals 4. The math here is basic addition, but really the problem asks you to recognize and put together clues. And that's why I like MathCounts. You need to have command of a nice range of mathematical facts, but mostly it's about logical and sometimes imaginative thinking.